Let's get into application of Bernoulli's principle and equation of continuity. Alright, now we know equation of continuity is A1 V1 is equal to A2 V2. Alright, let's see how are we going to apply it over here. Now this is an aerofoil. That's the designing of an aeroplane. Best example to consider. Now this is tube of air which is flowing through the aerofoil. Alright, now if we see this part and if we see this part, now the aerofoil is designed in such a way that the column of air that flows through aerofoil, if I make a tube over here and if I make a tube over here, this is bit flattened whereas this is elevated, owing to which if you see over here, the radius of this column is much lower than radius of this column of air. Alright, now we already know if radius is low, that means area is also low, and we know the relationship of equation of continuity. A1 V1 is equal to A2 V2. If area is less, then the velocity of air would be high. If area is more, velocity would be low. Now, there is relationship between area, velocity and pressure, which we had already seen in my earlier videos. Area 1, if I call this as area 1, area 2, area 1 is lesser than area 2. That's why velocity in 1 is greater than velocity 2, and since velocity 1 is greater, so pressure 1, that is pressure over here, is much lower than pressure 2. So pressure 2, assume it's atmospheric pressure, whereas here the pressure gets very low. Now since the pressure gets very low, so it becomes very easy for the aerofoil to move up. Now propeller are also there to further increase the velocity of air here. So further increment in velocity of air, further reduction of pressure and flight of plane, if we take aeroplane as our example. Alright, so this is what is the principle of aerofoil. Now let's get into biological example. Now this is an artery. Alright, artery, and obviously it appears to be very congested. Yes, it is. Why? Because of plaque. Whatever done in pencil is plaque on inner wall of arteries. Alright, now since inner wall of arteries, now see, this was the area of cross section of artery here, and this is the area of cross section of artery here. Yes, guessed right. The velocity of flow of blood over here would be much lesser than velocity of flow of blood over here. Rather, I should say that velocity of flow of blood would be much higher over here, owing to this constriction. Now since velocity is high, we already saw the relationship. If velocity high, pressure low, so too much of pressure from outside. Alright, low pressure, so surrounding pressure pushes the artery down, and since it pushes the artery down, so it gets constricted further, and as it gets constricted further, velocity increases further, pressure decreases further, again further constriction, and boom, heart attack. Okay. So let's understand what I have scribbled here. Heart exerts further pressure, V1 increases further, leading to repeated collapse, and which terminates to heart attack. Okay, so that's what happens. So this is the relationship that I have given over here. A1 V1 is equal to A2 V2. A1 is less than A2, so V1 is greater than V2. So P1 is lesser than V2. So this obviously is all P1, P1 C1s, V1s, and this is all A2, V2 and P2. Alright. So therefore artery collapses owing to external pressure. And who's the culprit? It's equation of continuity. Now don't blame on equation of continuity. It is your eating habits. Alright. Eating lots of fat, eating lots of junk food creates all this problem. So avoid it. Have healthy diet. Alright.